This is the introduction to section 3.5, part 1. In 3.5, we're talking about parallel lines and triangles. We're going to start to identify some specific characteristics of triangles. Objectives here is we're going to use parallel lines to prove a theorem about triangles, and that's what you're going to see here in part 1. You're also going to see here in part 1 to find measures of angles of triangles as well. Okay, so first postulate we want to look at, or the first part we want to look at here, is the postulate 3.3, the parallel postulate. It says through any point not on a line, there is one and only one line parallel to the given line. Okay, so here's what this is saying. Okay, as you notice, you have line L here. Okay, and they've put point P here. Right. And what they've done here is they've drawn, what they're saying is there is only one line that you can draw, which is the red line here. There's only one line that you can draw that will be parallel to line L. You cannot draw more than one. That's all it's saying. Okay. If I were to draw another line through point P, that's not parallel to L. Okay. Well, no matter what other line I draw, it'll never be parallel to L. There's only one line that is parallel to line, or one line that you can draw through point P that's parallel to line L. Okay. Now, the second one that we're going to look at is a very important one that you're going to use a lot and practice a lot, and that's the triangle angle sum theorem. Okay. The triangle angle sum theorem states that the sum of the measures of the angles of a triangle is 180 degrees. Sum means to add. So if I add angle A plus angle B and angle C, all three of those angles of a triangle add up to be 180 degrees exactly. Okay, so as we look here at these, and again, you may label these a little bit differently. You may say this is 1, this is 2, this is 3, and you would say angle 1 plus angle 2 plus angle 3 is equal to 180. The inside angles of a triangle, the interior angles, add up to be 180 degrees. Always, no matter what, if it's a triangle. Okay. Okay, now on the next page, let's flip it over and let's take a look at a proof and another example. Okay, this is proof of theorem 310, the triangle angle sum theorem. This is how they come up with the three angles of a triangle add up to be 180, and we're going to look at this one here. So, in here, they've done some things for us already. For example, in statement 1, it says draw a line PR through point B, which is parallel to AC. So we're talking about the parallel postulate. And as you can see here, here's line AC. Here's point B. If I draw a line through that point, there's only one that becomes parallel to it. So again, this red line here is parallel to AC. So what you may want to do is you may want to put a mark here on AC and on PR, so you know that they're parallel, because that's going to come into play here in just a little bit. Okay, it says angle PBC and angle 3 are supplementary. Okay, so let's take a look here. It says angle PB and C and angle 3, which is this guy right here. So those two angles add up to be 180, and my reason for that would be definition of linear pair. They're a linear pair, so I know they're going to be supplementary. Now, if it says supplementary, definition of supplementary angles for step 3, what I'm going to do is I'm going to take those two angles and add them to equal 180. So essentially this is going to be angle PBC plus angle 3 is equal to 180 degrees. Okay. All right. Step 4 now. Step 4 says angle PBC, which is this angle, the big angle right here, angle PBC, is equal to the measure of angle 1 plus the measure of angle 2. Well, you'll notice from this picture, 1 and 2 make up the whole thing. So this is really part plus part equals whole. So this, in this case, is the angle addition postulate. Angle addition postulate. Okay, now, what we're looking at now is step 5 is going to tie into 3 and 4. And if you look at 3 and 4, we say in 4, PBC is equal to 1 plus 2. And then we go to 1 plus 2 plus 3 equals 180. So we're tying these two together. And if you'll notice, what they've done now is they've taken this 1 plus 2, and they've replaced the PBC with angle 1 plus 2. So now it's 1 plus 2 plus 3 equals 180. This is the substitution property. Okay, substitution property. Now, in step 6, it says that angle 1 and angle A are congruent, and angle 3 and angle C are congruent. By alternate interior angles are congruent. Okay. Well, then in step 7, it says angle 1 is equal to angle A, angle 3 is equal to angle C, and it says congruent angles have equal measure. Again, this would be the same thing as saying the definition of congruent angles. So you can cross that out and put that if you'd like. That's how we're going to state it. Definition of congruent angles. Okay. And then the last one now, we know that our statement for 8 must be the statement from up here. So the measure of angle A plus the measure of angle 2 plus the measure of angle C equals 180 degrees. Okay. Now I want you to look, because these two, 5 and 8, are related to each other. They're essentially the same statement, except for now we have an A and a C in there. And if you look, it says that C and 3 are equal and A and 1 are equal. So essentially all they've done is they've replaced A for 1 and C for 3. So this again is the substitution property. Okay. Now, that's an example. If you look at the picture again, this is a way to prove. It says angle 2, which is this guy, plus angle A, which is this guy, plus angle C, which is that guy. If you add those 3 up, that equals 180 degrees. That's how you prove that 3 angles add up to be 180. Okay. All right, now let's take a look at another example here. And again, what you should do here is pause this and see, using the triangle angle sum theorem, pause this and see if you can come up with x, y, and z, and then take a look at it afterwards and see if you got it correct. And then that way you know whether to ask questions or not. So go ahead and pause and see if we can come up with the correct answer. Okay, now that you've paused and hopefully come up with x, y, and z, let's take a look at how to figure out this problem. This is what are the x values of x, y, and z in the diagram. We're using the triangle angle sum theorem. In other words, the 3 angles of a triangle add up to be 180. Okay, and as you look, I see 3 triangles. I see the big one, BAC, the big one. And then I see one on the left, BAD, and one on the right, BDC. Okay, and what I'm going to do, if you look at BAD, the one on the left, you've got 2 angles already, and then you have an x. So I'm going to be able to add those together. X plus 43 plus 59, and that has to equal 180 degrees. That's going to help me figure out x. So really this is x plus 102 equals 180. And if I subtract 102, x is equal to 78. So x is going to be 78 degrees. Now, you'll notice from the picture, as you look at these two right here, those 2 angles form a linear pair. And if x is 78, then y is going to be 102 degrees. Okay? If this guy right here is 78, this one has to be 102. Those two have to add up to be 180. And now, if you look at the right triangle, you have 2 angle measures here. You have this angle and that angle, and you can figure out z. So you could say now that z plus 102 plus 49 is going to equal 180 degrees. Or when you add these up, you should get z plus 151 equals 180. And then when you subtract 151, z should be 29 degrees. So you have a z, you have a y, and you have an x. Okay? All right, so we talked about triangle angle sum theorem, and we talked about how to prove that. along with the parallel postulate as well. This concludes section 3.5, part 1. Don't forget to complete your WSQ.